First Spin. Welcome to First Spin, a show where I learn how to use the Parallax propeller without having any prior programming experience. Rather than do this on my own, I have enlisted the help of Whisker and Roy.
What if we go on strike?
See ya.
Then I get to answer the questions.
Oh boy.
So, false today
all
means
the listeners
true.
are going to have some very strange coding practices.
Coding awesome.
Yeah, I don't
Addy
think that
gold
would work
standard.
so well.
They're going to do Lectureman J math, carrying the strawberry and such.
I suppose. But he's smarter than I am. I carry the mangoes.
All right, so last week you had us talking about the con block and all sorts of constants.
Yep. So we were finishing with X and Freak, which we've used before. False, you said last week, was -1. Float, and then true, on the other hand, would be 0, correct?
No,
True
it's
is
the other way.
-1.
Oh.
False is 0.
It's the other way around, and it has to do with the logical operations. You want 0 to be a false, right?
Oh.
And -1 in integer land happens to equal all the bits turned on of the integer.
That's strange. Why wouldn't it be +1?
Well, no, because
Binary.
positive 1 will only have the first bit turned on of the 32-bit value. But for a signed integer, -1 has all 32 bits turned on.
Huh.
It's FFFFFF or 11111 for 32 ones, right?
Interesting.
That's what -1 equals. So that's part of the reason why they use true as -1, because then you can use true to do things like mask against the whole set of I/O pins and stuff like that.
So then you could say dir A equals true, and then
Right.
all 32 pins would be outputs.
Right.
Oh, well, that's an easier way than doing 32 ones.
You can also go dir A and then just tilde, and it would do the same thing.
Right.
Oh.
That's the shorthand version.
Well.
Yep.
My gosh, that's a lot faster. Okay, and then float. I believe you hooked float, round, and trunk together, having to do with some sort of floating point math.
Well, we didn't cover that at all yet, but yeah. So the propeller normally in natively doesn't do floating point math at all.
And that, for those who didn't know, like I didn't, is any numbers stuff involving decimal points.
Well, right. It's like 1.5 instead of 1 or 2.
Right.
So, but the spin language does allow you to use floating point stuff during compile time, and also during runtime if you load in external floating point objects to help you do floating point math. Then you can actually do 1.5 times something or divide by 0.2 and get appropriate results, but you have to use special objects to do it.
So then without the objects, does it just round to the nearest integer?
Well, what happens is you during compile time you can use the float, round, and trunc keywords in your code, and as long as the results of like if you do a float of a number and then divide it by something and get some kind of result, and then use round or trunc to turn it into an integer and assign it to a constant, let's say, then the compiler, when it's compiling, will do all the floating point work for you and assign that integer result into the constant, and then use that integer result in the actual program.
I see.
If you're actually using the float math or float 32 objects to help you do floating point math, then when you have a floating point number
like 1.5,
if you have 1.5, that actually has a binary representation that fits into a 32-bit long value. And it's a special encoded form. And that's what those objects work with. And that's what this float command keyword does. It turns a number from 1.5 into that encoded form.
I see. So anytime
And,
you want to use floating point math or like decimals, in other words, you need to have float in your constants.
well, not in your constants. You can use it in the constant section. You can also use it other places in the code.
I see.
As you'll see when we get down to like the var section or the obj section or some of those, they also list float, round, and trunc as available in those sections. It's just a mechanism for you to do floating point math during compile time to get numbers that are useful in the ending result code that gets compiled, but it doesn't actually do floating point math at runtime unless you load the float math or float 32 objects to help you do it, and you call functions within those objects. They have like a f add, which you call that and it does a floating point add, and you pass in two numbers that you've converted into float or that are already floats because you did some calculations with them and stuff.
Sounds kind of complex just to add numbers with decimal points.
It
Yeah,
is. That's
it's
why
kind of
you'd want to use the objects to do this. They make it a lot easier.
Right. And it's for people that need the accuracy of floating point numbers and the precision, to do formulas that are based on real world things instead of just something they can convert to a completely integer form.
Right. So then what if you don't include this float biz and you just do floating point math anyway?
It will just give you an error when it compiles.
Really?
Yeah. If you try to do, if you just say 1.5 times 6 in the code, it'll eventually give you an error because the end result of that doesn't equal anything that the compiler can do anything with normally.
Well, 7 maybe. 1.5 times 7 might be.
Well, but it's still, you got to remember that the result of that is actually still a floating point number, even though it's 7, it's encoded in that alternate form.
Well, that's interesting.
Because it's really 7.0.
That's interesting. Okay. All right. Good. Very good to know then.
Eventually, you might end up doing some programs that might use floating point, but right now it's kind of advanced.
Right. Yeah, and for floating point math, if you can avoid it, do, because pretty much all processors will do integer math much, much faster than they can do floating point math. So if you can design your algorithm in a way where you don't need floats, then do.
Right. At least with microcontrollers, that's definitely true.
Interesting. Okay. NEGX and POSX. Sorry, I think
I talked about those last week, yeah.
Okay. So if you go down to page 93, which you can just click on the P93 there on that page that you're on that has all those.
Okay.
Notice that it's got
handy.
What each of those values equals.
Yeah.
True equals -1, and it shows you the hexadecimal for all the bits being on.
Oh, right. Okay, now I remember POSX NEGX.
So POSX is the maximum integer value that for assigned integer, which is 2,147,000,000, blah, 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 right? And NEGX is the same thing.
Okay. And then
and here's an example of that floating point encoded form I told you about.
Yeah.
See where it has pi equals approximately 3.141593?
Yeah.
And then next to it, see that 40490FDB?
Yep.
That's a floating point number encoded fit into an integer.
Okay. Gotcha.
But anyway, that's just sort of a, give you an idea of what's going on. So you can go back up to the other page.
Gotcha. That's handy.
And we can move on to the var section.
Yes.
It's actually really simple.
All right, let me get back to that. Okay. So var, these are global variables.
Right. So if you have a variable that you want to use across multiple different functions, sharing and not having to pass it into each of them.
Okay.
Right. So it's just a global. Usually people put their var section up at the top, but it doesn't have to be. It can be anywhere.
Okay.
And go ahead.
Oh, well, just to give an example to those listening, who, of when you would use global versus non-global versus local, actually. So I needed to have 2 cogs spawned for my heartbeat project, and one cog to do one half of the heart's, I guess, rhythm.
She
and
basically
then,
has two LEDs, and one of them is blinking one of the aspects of a model of the human heart, and the other one is blinking another aspect of the heart.
right. So there's one rhythm in which the two don't talk to each other. Normally they do, and so you could use a global variable for that because they're running in the same cog essentially. But there are other rhythms where there need to be two different rhythms altogether. And so in order to do that, I needed to spawn off two cogs, and in each cog, they had their own local variable, which if I believe is like pub, then the name of the cog, and then
Not the name of the cog, the name of the function. Because pub is defining a function in your program.
oh, I think of it as the name of the cog though.
Well, you can think of it as that, but I mean, cogs don't really have names. There's 8 of
they have
them, and
Well,
numbers.
yeah,
Zeros
there's
or
0 to
7.
7.
right. Okay, fine.
And
Number,
you
name.
can think of your cog 2 having a name, being it does this particular task, but it's really you're naming the function when you're doing pub.
Okay, so a function, and then you do your first variable space pipe symbol, and then space, and then your second variable. And if you need more, then you use more. So
Yeah, with commas separating.
yep. So
And
that's just an example of when I've used it in my
well,
programming.
that was for local variables, right? And you needed a global variable so that you could have a stack for
Yeah.
that when you started a new cog.
True.
You made a array in your var section
True.
would be the stack that you passed in when you did a cog new.
True. And so here we have bytes, longs, and words. I mean, I'm not going to worry about the float, round, and trunk, but the
Right.
bytes, long, and word. When do you decide which one you need to use?
Well, each one has a certain amount of range of numbers that it can handle, right? A byte can only handle plus or minus 127. Well, minus 127 to positive 128. A word is only 16 bits, so it's minus 32K to positive 32K. And then a long is the 2 billion plus or minus. So it's just it's a matter of how much do you need for what you're doing.
Like how many bits?
How many bits? Like it's the size of the variable. Like how much data can it handle?
Are you sure that bytes are signed, Roy?
They can be signed. They can be unsigned. It depends on how you use them, right? Just like anything.
Okay.
You can treat a long as unsigned if you want to.
Okay.
But
I think signed bytes are the work of the evil one, so I only ever use them as unsigned. 0 to 255 club represent.
I see.
Yeah. Well, let's see. I'm looking at the in spin expressions, byte value is interpreted as signed, negative 128 to positive 127.
Huh. Gotcha.
So
blasphemy.
Okay. And then object blocks define referenced objects. So I think we talked about this a little bit before in terms of they can be used as simplifying complex.
Well, as an
repeatable
example. Well, just as
functions.
an example, you use the I'm sure you've used the Parallax Serial Terminal object.
Yes, I have.
So that's where you would specify in the object block is that you wanted to use the Parallax Serial Terminal because you gave it I use PST colon and then the name Parallax Serial Terminal in quotes. That's including that object and assigning it to the PST name. So that in my program I can say PST dot and then any function that's inside of the Parallax Serial Terminal object I can call using that syntax.
Can I ask, can you name them anything? So could I say buddy colon equals parallax colon?
Yeah.
Wait.
Like he said he uses PST and that's what everybody uses for the Parallax Serial Terminal. But I made my own serial terminal, the Tymkrs serial terminal, but I didn't call it the TST. I use PAST just like everyone else
I
does.
see.
Right. And you could have called it Fred colon Parallax Serial Terminal, and then you'd have to use Fred dot, you know, TX or Fred dot string or whatever, to use the function that
Gotcha.
are inside there. Um,
Gotcha.
it's just an alias for that object within your code.
Mm-hmm.
And
Alias is an awesome word for programming, compilers, and all that sort of thing.
right. And you can have, you can list several objects to include here. You can even have an array of the same object
Hmm.
and use multiples. So if you wanted to use two serial terminals, you could say PST open bracket 2 close bracket colon parallax serial terminal. And
Oh.
that will actually create two instances of parallax serial terminal that you would have to then reference by using the array indexing mechanism.
Which I do with
And
SIDCOG.
how do you do that?
So you would say PST open bracket 0 close bracket dot start and give it the IO pins for that instance of the serial terminal.
Yeah.
And then you would do PST open bracket 1 close bracket dot start and give it different IO pins.
I see.
And then anytime you use PST 0, you'll be talking to the one serial output, and anytime you use PST1 in your code, you'll be talking to the other one. And so an example of using that would be one of them could be talking to a serial LCD display, and the other one could be talking out to the debug port hooked up to USB, hooked up to your computer, right?
Mm-hmm.
Like the normal mechanism for PST. And there's lots of other advanced uses of that. Like you could have a servo object that drives a servo, and you can have an array of 4 of those to drive multiple servos.
Gotcha.
And you would just reference them by their index in the array, right?
Yeah.
So,
A couple of weeks ago, we mentioned that every time you use uh, a numbered array of things instead of literal names for things,
Mm-hmm.
it makes it easier to create algorithms around them that can do something with this or something with that.
right,
So your one algorithm loop can control more than one servo that are on more than one cog.
Mm.
right. Or going back to the PST example, you could do a repeat loop from, you know, of 2 counts and send the same string to both places, because you can just do repeat X from 1 to 2, and then PST sub, I'm sorry, 0 to 1, not 1 to 2. And then PST open bracket X, close bracket dot string, blah, 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 whatever you want, right? And loop over, and the repeat loop will do it twice and send it to both instances of the PST object because it's in an array. Now, alternatively, you could have gone, Fred equals parallax serial terminal and Joe equals parallax serial terminal in the object section. You could have done that and used them as just Fred dot and Joe dot, and that would have worked also.
Dr. Joe. Okay.
Gotcha.
So I don't know. She looks like she's getting a little bit glassy-eyed over here with this. I may have to take a little bit of time and actually show her an example, and I think that'll make a lot more sense to her.
Yeah, it's pretty easy once you see it in action.
Right. I mean, I kind of get it, but like, I just don't know when I would use it.
Well, it's sort of an advanced thing. The main thing is for your what you're already familiar with is it's where you would list the objects that you want to use in your program, like Parallax Serial Terminal and various other objects out there,
Mm-hmm.
and you give them a name, and then you use that name down in your pub functions to actually use those functions that are in that object.
Which she's done before, and she understands all that.
Right.
It's more the arrays of them that got her a little confused.
Yeah, I'm sorry. I was just trying to explain an optional ability
Nope, that's
that
cool.
is used more often actually than some people understand. I mean, I use it all the time.
Yeah, me
for
too.
things. It's pretty handy.
Gotcha. And I've used it in the project. Also actually the very first iteration of the Heart LED project. I needed to figure out which direction the resistance went for
Mhm.
a what are those things called? those little photoresistors.
Cadmium cell?
Yeah, cadmium
Yeah.
cells, photoresistor. So I needed to figure out which way the resistance went when I brought my hand closer versus farther. And so
Right,
the way
right.
that I did that was by having it read its resistance values to the Parallax Serial Terminal.
Right. So
And that's
you've
how I
used the
saw it.
OBJ thing with Parallax Serial Terminal, yeah.
Right.
Yeah, and that's the first one that most people learn how to use so that they can figure out what's going on inside their program using the serial terminal.
Right. Right.
It's a very handy tool.
Right. Okay, so we'll move on to pub and pry, and I don't think we're gonna go through all of these. I don't think I need to.
Yeah.
I mean,
We
it's a
can just
lot, but
we can just do like a quick little overview. First of all, pub and pry are public and private. That's what they're short for.
okay.
And public is just a designation saying anyone can call this. If this function was inside of an object that you included from the OBJ section, you'd
Mm-hmm.
be able to call the pub functions. You won't be able to call the private functions because
Okay.
they're hidden from the outside. So that's the designation between public and private. That's the main thing to need to know about that. And pub and pry is where you actually put all of your code. Like your actual spin code that you want to run is inside of a pub or pry function somewhere.
So pry, what do you mean by can't be seen?
Well, so private methods or functions can only be called from within the same spin file that they are written in. Right? So like you have your heart program, right?
Yeah, yeah.
And if you have a private function in there, then you can only call it from within that heart program.spin file. But if you included that heart spin file as an object in another program,
Yeah.
then that other program would not be able to call the private function within the heart program.
Well, that's handy. So couldn't you, like, if you didn't want people to steal your code, you could just stick it in private?
Well, it's not a matter of stealing your code because it's not hidden. You can still go look at it and see it.
Oh.
It's just a designation for the compiler to block access to that function because it's generally for functions that would not normally be needed by the other program, right? So inside of PST, there's a bunch of functions in there that you can call that output to the serial port, right? Well, there's a few internal functions that you can't call that are actually do a little bit of the work to help the serial terminal object actually function.
Mm-hmm.
And those are private, and that's all that's really used for. It's just it's more of an organizational thing, and it enforces that rule so that you don't accidentally call a private function that might mess things up.
Sure. Huh.
'Cause
Well,
you-
that's too bad because that'd be cool if you had like secret passageways in like spin so that there's actually port B. You just can't
Yeah.
find it because it's in private.
I use DIRB all the time because I'm elite level like that.
Right, but it doesn't actually connect to the outside world.
Gotcha.
You're-
Okay.
You're breaking my rainbow wishes here. My dreams and hopes, they're all just collapsing. Here, I thought that like port B was like a connection to some kindred prop somewhere out there, but no,
That's
there
too
is
bad.
no port B.
All right. Okay, and then DAT. Data blocks. I don't know. Have I actually used DAT?
No, you haven't used
I
that
don't
yet.
think I have. So data
So-
blocks define data and propeller assembly. Oh, well, it's assembly.
Yeah, primarily the DAT block is where you will have all of your assembly code. You don't really use DAT blocks when you only have spin in your program.
I do.
You can for some advanced things, but in general, you don't have DAT blocks.
Like what I've used it for in the past is if you have to outline a long string of things that never changes,
Mm-hmm.
I'll put it in a DAT block,
Mm-hmm.
and then I can access it just by going to a particular byte in a long string of bytes.
Well, yeah. So one of the things that a DAT thing can do is instead of having a variable up in the var section that you then have to write code to actually assign values into it, you could have a label in the DAT section and plug in the numbers yourself, type them into the actual code, and then at runtime the code can just use that label and access those numbers, that data. I mean, that's basically what Whisker is saying.
Yeah, it's an
it's allowing
easy
you
way to basically lay out a section of memory in exactly the way you want it laid out right there in the code.
Right. And again, that's somewhat of an advanced feature. It's not common to do that kind of thing, except maybe for strings. Some people will put their strings in a DAT block so they can print out, friendly messages on their LCD display or something like that.
I use it to like make tables to be able to convert notes on a keyboard into registers for SID-cog.
Right.
Handy for that kind of thing.
Yeah. There's lots of uses for it, and again, it's got some similar constructs to the var section, but it's a little different. But you basically have byte, long, and word. There's also a whole bunch of much more advanced stuff you can do with the DAT that involves propeller assembly code.
It sounds
which is
kind of
way
like,
beyond the scope of this show.
It sounds kind of like Google Plus versus Twitter. So Google Plus, you can say like a whole bunch of stuff in one block, whereas Twitter, you only have 140 characters. So it's like data versus variable. Or data versus con.
It's not really like that. It's more like I don't know. I don't know what it's more like, but data is it's akin to con, but con is like a single label equals a single value, right?
Yeah, it's a bit more like a spreadsheet, Addy.
Yeah,
it's like got a bunch of cells that you can change.
You can put a bunch of data in a DAT section and then access it with your code, and that data is typically constant data that you just fill in with information. You can actually put
Can you change it on the fly?
In assembly you can. I'm not sure in Spin. I've never actually tried.
Oh.
But when you're using propeller assembly language, that DAT section is pretty much all that you use. Like all your assembly code and all your data variables and everything are all in there because all of that stuff ends up getting compiled and put into the cog.
I see. Well, since we're doing first spin, luckily I don't have to worry about it too much. So,
but there's one thing I would like to add is that in the DAT section, instead of having typing in a whole bunch of numbers, like you could say byte and then list out a whole bunch of bytes that are some value that you typed. You can actually specify the file keyword in the DAT section and then give it a file name in quotes, and it will load that file and put it into your program right where that DAT section says to put it.
Oh, that's handy.
With a label. And that's, I believe you use that for your, when you played a WAV file.
I had to be honest, I don't exactly know because I didn't really study the object too much. I think I tried.
Okay.
But
so anyway, what it did there is that in a DAT section, it had a label for heartbeat wave file sound, right? And then it put this file keyword in and put the name of the heartbeat.wave, the actual file on disk. And then when the compiler hits that, it will load that file and stick it into the program at the appropriate place and give it the label that you put in there in the DAT section, so that in your code you can then use that label to access the data that's in that file.
So you pretty much get that, Addy?
Yep. That makes sense.
It's excellent. That's it for this week. That's all the time we have.
Egads.
Yeah. Thank you, everyone, for listening. We've been seeing you guys talking about us on Twitter and the forums and all over the place. Thanks for all the links and
the support.
Yeah, sharing this with other people that might find it useful. Makes it a lot easier to get it out there to the folks who really need it. So even if you already know this stuff, it's really helpful if you sort of pass it around.
Yup.
You can find the show every Tuesday on firstspin.tv.
Correcto.
We'll see you guys next week.
Bye.
Bye.
See ya.